In this section, we're going to look at the relationship between position versus time graphs and velocity versus time graphs. We're going to review some of the basics about position versus time graphs, and then look at how we would translate those position versus time graphs into the velocity versus time graph and understand what each velocity versus time graph shape would mean in relation to motion. A few reminders about position versus time graphs. The slope of a position versus time graph is the velocity. That's going to be very key to us in this part as we look at velocity versus time graphs. We need to be able to look at the slope in our position versus time graph to understand where that velocity is coming from. Since slope is what gives us velocity, there are a couple of things that we can read from our position versus time graph based on the slope of the lines or curves. With a horizontal line, that means that you are stopped or not moving at rest. So anytime you see a horizontal line in position versus time graph, that means that you are stopped. Straight lines means that you are moving at a constant velocity. So horizontal is also a straight line with just a slope of 0. So a constant velocity of 0. Now if it has a positive slope, it's moving in the positive direction. If it has a negative slope, it's moving in the negative direction. So anytime you see a straight line, you have a constant velocity. Curved lines mean that the object is accelerating or changing velocity. If the slope is increasing, then you are speeding up. If the slope is decreasing, then you are slowing down. I want to go through each case here, draw the position versus time graph and the corresponding velocity versus time graph for each of the cases of motion. So we're going to start here with the case of position versus time for an object that's standing still. So if I draw my two axes, apologies, these aren't perfectly straight, a position versus time graph with still motion would be completely flat. The further you are away from the 0 point, the further the position is away, but this completely flat line would be a position versus time with not moving the 0 velocity. So on velocity versus time, you'll notice that our velocity versus time, we're going to have a lot more that are in the positive and negative, so we'll generally draw the axes with area for both positive and negative velocity. Here, our velocity will be right along the x-axis, so it will be a velocity of 0. Constant velocity in the positive direction. In this case, we've got our position versus time. The constant velocity in the positive direction would look something like this. For v versus t, what that's going to mean, since it's a constant velocity, it's staying the same and it's positive, whatever the value is, it'll be a straight horizontal line at that value. Constant velocity in the negative direction. In this case, our position versus time is going to look something like this. So our velocity versus time would be constant, but now with a negative value, so whatever the value happens to be, it'll be a straight line in the negative portion of the graph. Speeding up in the positive direction. Our 4 cases remaining are all cases where we're changing velocity, so these means we will have curves in our position versus time. Speeding up will look something like this, where the slope is increasing. You'll notice here the slope is 0. At this left side where it's almost flat, and then here it's pointing almost straight up, so the slope is very, very large. So our velocity versus time graph, in this case, started at 0. So we'll start down here and is increasing, so we'll get a diagonal line that's in the positive. Slowing down in the positive direction. In this case, our position versus time starts relatively steep and levels off. So our velocity versus time will be a relatively large positive value, getting smaller. In this case, where I drew it flattening off here, would get all the way down to 0. Speeding up in the negative direction. So now we're going in the negative direction, so our position versus time graph will be moving down the position versus time graph and speeding up. So it starts at 0 and then the slope increases. Our velocity versus time graph will start at a velocity of 0 and increase on the negative side of the graph, so we'll get a straight line. Slowing down in the negative direction, in that case, position versus time, instead of speeding up like we had last time, this time it will start relatively steep and level off to 0. So our velocity versus time graph will start with a relatively large negative velocity and go to 0. So a couple of key reminders about your velocity versus time graphs. A velocity versus time graph shows the object's velocity as a function of time. A horizontal line means a constant velocity. If it's on 0, that means a constant velocity of 0 or standing still. A straight slope line means you have a constant acceleration. If that slope is positive, it is a positive acceleration. And if that slope is negative, it is a negative acceleration. Now, a couple of things. Acceleration is defined as the change in velocity over time. So anytime we do slope, change in y over change in x, or change in v over t, so the slope of the velocity versus time is our acceleration. A positive slope means you have a positive acceleration, a negative slope means a negative acceleration, and please understand the positive slope does not mean necessarily speeding up, and negative slope does not necessarily mean slowing down. If the v versus t line has a positive slope, the object is undergoing acceleration in the positive direction. If v is also positive, then the object is speeding up. If v is negative, then the object is slowing down. So what this would look like, this first case, your v versus t, if it's got a positive slope and it's got a positive velocity, that would be speeding up. A positive slope but a negative velocity, the second case, would look like this, and that would be slowing down. Same thing with the negative slope. If you have a negative slope but a positive velocity, you're slowing down. Something like this. And a negative slope and a negative velocity is speeding up in the negative direction. So if the slope of the v versus t and the v versus t graph are both positive or both negative, you're speeding up. If they're opposite values, you're slowing down.